Welcome to lesson number 3. We're going to be looking at the trig ratios again. Now, the sine ratio, cosine ratio, and tangent ratio, these three are going to be pretty familiar. And these are the ones that you've been looking at since grade 9. So, sine, still opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tan is opposite over adjacent. Now, the differences are reciprocal trig ratios. And so these are the new ones that we're going to be looking at. So first of all, we have cosecant ratio. Cosecant is, the shorthand is CSC theta. Now all cosecant ratio is the reciprocal of a sine ratio. So the cosecant of theta is equal to 1 divided by sine theta. The secant ratio is equal to the secant theta, and that is equal to 1 over cosine theta. Then we have cotangent ratio, which is 1 over tan theta. One way to remember this is if you have sine, cosine, and tan, they all pair up with one co. So if it's sine theta, that's going to go with cosecant ratio, or cosecant theta. If it's cosine, it's going to go with the secant theta. And then tan theta is going to go with cotan. So with our diagram, if we were to express all the ratios in terms of x, y, and r, and this is what we did in pre-calculus 11, we can use this diagram over here just to kind of guide us in forming these trig ratios using the terms x, y, and r. And so if I was talking about my sine theta, remember, is opposite over hypotenuse. Now remember, my hypotenuse in these trig ratios is my radius. If I look at a unit circle, my radius is my hypotenuse. My x is my adjacent side, if this is theta, and my y is the opposite side. So if I'm looking at my sine theta, the ratio would be y over r, or the opposite side over my hypotenuse. Which means that the cosine would be the adjacent side, the adjacent to this angle, over the hypotenuse. So that would be x over r. And tan, well, that's the opposite over the adjacent, or the y over the x. Now, when we're looking at the cosecant ratio, the secant ratio, and the cotan ratio, remember, those are just the reciprocals of all of these. So if I'm looking at cosecant theta, that's the reciprocal of sine theta, meaning it's going to be r over y, so the radius over y. Secant theta, that's the reciprocal of cosine theta. That means that's going to be the radius over my x value, and cotan theta, or cotangent theta, is going to be x over y. So there's different mnemonics that you can use to remember these. Common one is 7 yellow rabbits for sine theta, y over r. But you can make up your own if that's easier for you to remember. Another thing we did was we thought about where are each of these ratios positive and negative. So if I have sine theta, cosine theta, and tan theta, what were the signs for each of these? So were they positive or negative, or what did they actually look like? So with this example, we're just going to be placing my x and y, and we're going to be thinking about where they're positive and where they're negative. So if I'm looking in quadrant 1 here, I have positive x, and I have positive y followed by positive r, meaning that if I'm looking at sine theta, which is y over r, those are both going to be positive. If I look at cosine theta, which is x over r, well, I have a positive x and I have a positive r, which means that my cosine ratio is going to be positive in quadrant 1 as well. Tan theta, well, tan theta, remember, is y over x, and again we have both of those ratios that are positive in this quadrant, making the overall ratio positive. If we move over to quadrant 1, sine theta is still y over r. But if I look at my y value, my y value is positive. My r value also positive. And in fact, the r value is always going to be positive, which means that the overall sine ratio in quadrant 2 is also positive. Now if I look at my cosine ratio, x over r, well, x now is right here, and that is negative. My r is positive, but the overall ratio for cosine in quadrant 2 is negative. With my tan theta here, tan theta is y over x, and y, remember, is positive, it's going up. X is negative still, so the overall, my tan ratio is negative in this quadrant. If I move down to quadrant 3, we have y over r, y is negative, r still positive, overall ratio negative. With my cosine ratio, I have x over r. My x is negative, my r is positive, overall is negative. Now if I look at my tan ratio, y over x, well, y is negative, going down, r negative, going to the left. A negative divided by negative is a positive. So the overall ratio there is positive. Now last I have my sine ratio again, so that's y over r. Y is negative, r is positive, leaving me with an overall negative ratio. X over r, x is positive, r is also positive, giving me an overall positive ratio with my cosine. And I have my tan, y over x again. Well, y is negative, x is positive, overall negative ratio. So the reciprocal trig ratios actually follow the same as their corresponding primary ratio. So for example, if I was looking at the sine ratio, the sine ratio has the reciprocal of the cosecant. And so the cosecant is going to have the same signs as the sine ratio in each of these quadrants. So in quadrant 1, cosecant will also be positive. In quad 2, cosecant will also be positive because sine is positive. So if I were to fill in this section here, sine ratios and cosecant ratios have positive values in quadrants 1 and 2. Cosine ratios and secant ratios have positive values in quadrants 1 and 4. And then tan ratios and cotan ratios have positive values in 1 and 3. Sine ratios and cosecant ratios have negative values in quads 3 and 4, so wherever they're not positive. Cosine ratios and secant ratios have negative values in quads 2 and 3. And then tan ratios and cotangent ratios have negative values in quadrants 2 and 4. And if you don't want to do this each time, which you really shouldn't do, you should actually memorize these. And one way you can memorize is remember the cast rule. So cast, starting from the bottom right, C-A-S-T, or you can remember from top right all the way around is add sugar to coffee. All ratios are positive, sine ratios are positive, 2 tan ratios are positive, and C, cosine ratios are positive. But remember now we need to remember that all ratios still encompasses all, but sine ratio is positive, but also the cosecant is positive here. Tan and cotan is positive, and then cosine and the secant ratio is positive here. Alright, so in this example, class example number 2, I'm going to do A, E, and C. We just want to, without using technology, determine whether the trig ratios are positive or negative. So sine 280 degrees, well, if I draw apart my grid here, if I have 280 degrees, I know 270 is around here, so 280 is going to fall in this position here. And if it's positive, then it's going around in this direction. That's going to end in quadrant 4. And if I'm looking at the sine ratio here, in quadrant 4, the sine ratio is negative, because in quadrant 4, the only positive ratios are the cosine ratios and the secant ratios. Cosine 10 pi over 3. So we're going to do the same approach we did with the last one. We'll draw our grid, but now we want to find out where this angle is. So if I have cosine 10 pi over 3, well, let's first of all think about where 10 pi over 3 is. I would be going around, I would do 3 full loops around, and then I would end right here. And one way you can think about that is, well, how many times is 3 go to 10? It goes into 10 3 times. Then we'd have a third left over. So I got 1 all the way around, 2 all the way around, and my third all the way around. And I would land right here, around here somewhere. So we're in quad 3. And in quadrant 3, we have cosine, which is also negative. And actually, I'll do a couple more using the using radians. So I'll do b as well. So if I'm looking at tan theta, or sorry, not tan theta, but tan 7 pi over 6. Well, if I have 7 pi over 6, I have 1 full pi plus a 6 left over. And so if I have a full pi and 1/6 left over, then pi, remember, is right here, starting from 0. And then a little bit left over would give me 6 left over, and I would be in quadrant 3 again. And if we're looking at the tan ratio, in quadrant 3, we're going to be positive here. So we had negative, positive, and negative. Now let's look at, I guess it doesn't matter. Let's look at D and E. So with D, we're looking at the cosecant this time, right? So cosecant, we're at negative 225 degrees, all right? So if I'm at negative 225 degrees, then I'm going around, and if this is if we were to go all the way around this way and land at 270, then I'm turning this way. This would be negative 180 plus a little more over here would be 225 degrees. So I'm landing in quadrant 2, and cosecant is the reciprocal of sine, so that means this is a positive angle in quadrant 2. So we landed in quadrant 2 here. And last one we'll look at is the cotan of negative 13 pi over 6. So negative 13 pi over 6. All right, so let's think about what's happening. We're starting here. And so if we're starting at the standard position, we're now going all the way around. Now, 6 goes into 13 twice, which means we were 2 pi with a 6 left over. So we're actually doing a full rotation. So here would be 2 pi, but we're actually at 2 pi and a 6th. So we're ending right here again. Well, not again, but this is where we're ending. And this is quadrant 4. If we're looking at the cotan, remember that's the reciprocal of tangent, which means here my ratio is positive. All right, so this is the moment everyone's been waiting for, is using that radian function in your calculator. So with your radian function, we can convert from using pi's, or using like actually determining what the value of radian is when if we were to type out that ratio in our calculator. And so this is one way to do it, to actually calculate using cosecants with your radians in your calculators. So there's no cosecant button, there's no